Solve the inequality 3x minus 5 all squared is less than or equal to 3x squared plus 1. So solving an inequality, we're in this case solving for x. So we need to find the values of x so that this left-hand side is less than or equal to the right-hand side. So for example, we could just, if you have no idea where to start, we could just take a guess just to see what it looks like. It won't be extremely helpful, but you know, it's good to try. So let's guess 1, just keeping it simple. If x was 1, what does this left-hand side become? Right, so that's 3 times 1 minus 5 all squared, which is 3 minus 5, so that's minus 2. Minus 2 squared is positive 4. And we want to see, alright, is this actually less than or equal to the right-hand side when x is 1? So that would be 3 times 1 squared plus 1, which is 4. So hey, that was a pretty good guess. When x is equal to 1, this inequality is true. But if we tried, let's say, x equals negative 1, it might not work, right? I mean, and we're not going to sit here all day and try every possible value for x because there's literally infinitely many. But this is just a way to start building some intuition. Okay, so I encourage you to try a few more values. You might be able to work it out like that. However, we're in level 1, so we can solve it algebraically. To do so, let's expand the left-hand side first. Alright, so 3x minus 5 squared is times itself like that. We can't simplify or expand the right-hand side because those are unlike terms, and that's already expanded. So back to the left-hand side, 3x times 3x, we'll FOIL this out, becomes 9x squared, and then minus 15x, minus another 15x, and then careful here, minus 5 times minus 5 is plus 25. And while we're here, since I can rub this out easily, you might not be able to, just use another line, that's fine. Minus 15x becomes minus 30x. So I just grouped like terms. Just saving some space for myself, but you can do this in a separate line, that's no worries. Less than or equal to 3x squared plus 1. Awesome. Now I see some x squared terms floating around, which makes me think we're going to have a quadratic. And just like solving a quadratic equation, when we have an inequation, we want all the terms on one side is less than or equal to 0, or is greater than or equal to 0. So that we can then factorize. So let's subtract the 3x squared from both sides and the 1 to bring everything to the left. So we get 9x squared minus 3x squared is 6x squared minus 30x plus 25 minus 1 is plus 24. And since we subtracted that, we're left with 0 on the right-hand side. Cool. I do see a common factor in these three coefficients here, common factor of 6. So I'm going to simplify the problem and divide both sides by 6. So on the left-hand side, we have x squared, then minus 30 divided by 6 is minus 5. 24 divided by 6 is plus 4. So always be on the lookout for, when you're solving a quadratic equation, can you divide it by a common factor to simplify it? Great, now we can factorize. So on the left-hand side, factorizing multiplies to positive 4, adds to negative 5. That would be negative 1 and negative 4. Awesome. So if this was an equation, right, if it was an equal sign, we would then set both of those brackets to 0 and we'd get x equals 1 or x equals 4. and then we're done. However, this is an inequation, right? It has an inequality sign. So there'll be a range of values for x. It won't just be 2. It will be either between 2 values or outside of 2 values. So the options are for here. So we solve it like normal and we get x equals 1, x equals 4. However, this tells us that x is either between 1 and 4 or x is outside of 1 and 4. So x is less than or equal to 1 and greater than or equal to 4. Right, so just on a number line, if we have 1 and 4, this solution is saying x is between those values, whereas x is less than 1, less than or equal to 1, and greater than or equal to 4 would be these values outside. So those are the two possibilities. So we need to work out which one it is. The easiest way to do that is, all right, once you've got here and you've worked out, all right, my boundaries are 1 and 4, like on this number line, pick a value for x in the middle, right, in between. So let's say 2. Doesn't need to be perfectly in the middle, right, that's fine. 2. Now, what we do is take 2 and substitute it in for x. So we have, I'll just do it up here, 2 for x, 2 for x, and now is that less than or equal to 0? Interesting, 0, 0. If it is, that means our range is between 1 and 4. If it's not less than or equal to 0, then our range is outside of that. So let's check. 2 minus 1 is 1. Times 2 minus 4, that's times negative 2, which is negative 2, which is less than or equal to 0. So that tells me our value for x must be this blue one. It must be between 1 and 4. And it's not the one that's outside of that range. So let's recap this one. Solving an inequality. In this case, we expanded the left-hand side. We realized, it's going to be a quadratic. Makes it a little bit harder. But that's fine. We took everything to one side, and we had what looked like a quadratic equation, right, in standard form, except we had it in an inequation. We factorized like normal to get our values 1 and 4. So those are our key values, 1 and 4. And then we needed to determine if x was either between those values or outside of those values. Can't be both, and it has to be 1, right? And we picked a number between just to try it out, and it happened to work, right? This is this rough working over here. And since it worked, we know that x must be between 1 and 4 inclusive. Right, and I didn't mention that too much, but it's inclusive because we had this less than or equals to sign. But if it was just less than, our final answer would be 1 less than x less than 4. So just a subtle difference there, but in level 1, you can write either and you'll still get full marks.